Yes, dear students, till now I have told you Gauss theorem and electric field due to Gauss theorem at different points. Now I will give in this video some numerical problems from board exam and from NCERT book also. Here is one question. It is a conducting cell. Conducting cell whose inner radius R1, outer radius R2. It has charge capital Q on outer surface and small charge Q at center. Charge capital Q on the surface and small q at center. So you are asked find the surface charge densities at the inner surface and outer surface and write electric field or find electric field at a point whose distance from center O. Center O you can say here is greater than R2. So first of all, this is conducting cell, means made up of some conducting material like some metal. So due to that, that has free electron, so there will due to electric induction on the inner surface, there will be minus Q charge. And as a result of this, plus Q charge will get induced outside also. And hence, surface charge density at inner surface is equal to minus Q upon 4 pi R1 square. Because area of sphere, this is sphere here, 4 pi R square, so inner radius R1, and similarly surface charge density of outer surface. So now is equal to capital Q plus small q upon 4 pi R2 square. A simple case, and then he asks you what is field at the point P at distance x. So according to Gauss theorem, if we imagine here Gaussian surface, then people may get confused. Okay, surface from Gauss theorem you can write here. E into 4 pi R square x square E dot ds integration, total charge inside. So you may think by minus q plus q. Actually plus q minus cancel हो गए, and total charge inside is q plus small q upon epsilon 0. That's all. And hence E is equal to 1 upon 4 pi epsilon 0 q plus q upon x square. That's all. This is a simple question. I have seen while checking copies, most of the students could not attempt this question, while it was a simple question. Now there is another similar question here. Again, question number 2 कह लीजिए. So what is that question? Again, it is a cell, hollow conducting cell having inner radius R1, outer radius R2, and at center there is small sphere having charge Q. A small sphere having charge Q here. So you are asked here कि and a small sphere of having charge q is located at center of the spherical cavity in a large uncharged metal sphere. So charge q here, find field at point P1 and here at P2. You are asked here, find electric field at P1 and P2. And how the electric field will be affected if inside this cavity is filled with some dielectric medium. So actually, a small sphere has a small means radius negligible small. So at point P1, so simple. If we consider Gaussian surface here again, then E into 4 pi R1 square is equal to Q upon epsilon 0. So this E is equal to 1 upon 4 pi epsilon 0 Q upon R1 square. That's all. But at this point P2, presence of this charge will induce the same negative charge on the inner face. Minus Q charge will be induced inside this, and therefore at point P2, if we write apply Gauss theorem, 4 pi R2 square equal to total charge inside plus Q minus Q upon epsilon 0, and this is 0 here. So E equal to 0. At P2 electric field will be 0. Is that clear? वैसे भी inside a conductor. देखो, this is conducting cell. This material is there, metal. So no charge can exist, or no electric field is there inside a conductor. This is a property of conductor. So please learn Gauss theorem. Till now, actually I have told you, Gauss theorem says that integration E dot ds is equal to Q upon epsilon 0, and this is called electric flux phi equal to Q upon epsilon 0. Then I determine electric field due to long linear charge distribution, that E was lambda upon 2 pi epsilon 0 r. And then due to charge conducting cell, and here we got different formulae outside 1 upon 5 q by r square at surface E equal to 1 upon 4 pi epsilon 0 q upon r square, and also sigma upon epsilon 0 at surface, and inside here E equal to 0. Then I told you electric field due to plane charge sheet. If this is a sheet here having infinite size, point P close to it, then E equal to sigma upon 2 epsilon 0. Sigma is surface charge density. Here the sigma also surface charge density. You can see them in the previous videos. Then I did field due to two plane sheet, etc. So please remember them. Now I am going to solve a problem from NCERT book here. What is that problem? Solved example and important, has been asked in board exam twice. Here is a cylindrical surface. Let me do it next.